All right. When it comes to multiplying rational expressions, our job is to ultimately simplify, is to see if we can possibly get some things to cancel, vertically reduce or diagonally reduce, but really it's not a diagonal since this multiplication makes this one big fraction bar. So my encouragement when you get a rational multiplication problem is to factor everything first, which feels counterintuitive because you're actually dividing rather than multiplying at your first step. So first thing I'm going to see is that there are 4 parts to this particular problem, and I'm going to look in each place to see if I can factor this. Bottom right-hand corner, you can see I have already, my brain just says, oh, it's going to need 2 parentheses. And then up top, I'm like, hey, there's some difference of squares right there. And so I'm going to factor that one like this. And then this top left corner, it's just an x squared. There's nothing going on there. But then right here, I look at this 4x plus 8, and my brain immediately says, hey, those have a 4 in common. So those are the things that need to be going through our mind when we see these problems. So one at a time, we're going to factor them. So top left-hand corner, check, nothing to do there. Bottom left-hand corner, these have a 4 in common. So you divide each of those by 4, and this gives you x plus 2. And now we move to the top right-hand corner. And this is difference of squares. So we make it x and 2, x and 2, because those are the square roots of those two values. And then it's just a plus and a minus. That's how the difference of squares works. And then this bottom right-hand corner is a magic x problem. So if we put a negative 16 on top and a 6 on the bottom, we just have to figure out that our magic numbers are 8 and 2 with a negative on the 2. That gives me a negative 16 and adds to be a positive 6. And of course, because the a value is 1, we get to just use these magic numbers as our factors and get x plus 8 and x minus 2. Now, for the sake of clarity, I'm going to rewrite everything to the right here so that we can vertically reduce. And I'm going to put one big fraction bar with everything squished together. So x squared times x plus 2 times x minus 2 over 4 times x plus 2 times x plus 8 times x minus 2. Now, it would be very diligent of us to go ahead and name our points of discontinuity before we start reducing. That x can't be a few things, negative 2, negative 8, and positive 2. The problem didn't call for that. Sometimes the questions do call for that, but this time they do not. Anyway, our job is to vertically reduce anything that is a like binomial or like term as a product. So I see my x plus 2s, I can reduce those out. And I see these x minus 2s. Those are big diagonal-ish ones, but those are ones. Anything divided by itself is 1. So 1 there, 1 there. The only thing left in the numerator is this x squared. In the denominator, we have the 4, and then the x plus 2. So our job is to just multiply straight across now with what's left. So I'm going to write off to the side here, x squared over, and then it's just 4 times x plus 8. So I'm going to put 4 times x plus 8. And I'm going to leave that in factored form and call that the simplest form. You could distribute the 4. It depends on the context of what the question calls for, but I prefer it to be in this factored form. All right, in this second example, we're going to do a very similar process where we're just looking in each of the 4 locations for the factoring that we can do and then vertically reducing. So in the top left-hand corner, start there. I recognize I have x's in common, and then the greatest amount they have in common is the lowest exponent. So I'm going to factor out an x to the third. And then if I divide out an x to the third here, that turns into an x to the 1. And then plus this x to the third is gone, so just 8. So that top left corner's done. The bottom left-hand corner, there's nothing to do there, so just kind of check off. I thought about it, nothing to happen. And then this top right-hand corner, I got difference of squares, so you set up 2 parentheses, square root each square. That gives me x and 3, plus sign, minus sign, factored. Now the bottom right-hand corner, I've got a magic x problem. So at the top of that, I got 24. Bottom, I have 11. And then I look to multiply to be 24, add to be 11. Sounds like 8 and 3 to me, and both of them positive. So because there's an a value of 1, I can just jump to the magic factors with my magic numbers and get x plus 8 and x plus 3. Now, I'm going to go ahead and rewrite it for clarity's sake with everything squished together. And so I have x to the third times x plus 8 times x plus 3, x minus 3, over 8x times x plus 8 times x plus 3. Anything that is found in the numerator and denominator over itself can be divided out, because anything divided by itself is 1. So x plus 8's, x plus 3's. And then I also have an x down here and 3 x's up here. So I'm going to take and reduce 1 out. So one of these x's makes this 3 turn into a 2x squared. And so now I multiply what's left, and I'm going to put that right down here. And so we're going to have x squared times this x plus 3, minus 3, divided by 8. And that's it, because the bottom is this, a 1, a 1, and a 1. So this is the simplified rational expression. And if I had called for also asking for points of discontinuity, you should have answered before you cancel everything out. But there would have been a 0 right here, so x can't be 0, can't be negative 8, and can't be negative 3 from each one of these factors in the denominator, because we cannot divide by 0. All right, in this third example, we have division. And remember, division is really multiplication of a reciprocal. Before I rewrite it, though, I am going to factor just to save myself one rewriting on the screen here. So I'm going to factor this left-hand fraction. So the numerator is a magic x. And so I'm going to make this a 20 on top, negative 9 on the bottom. And then I multiply with 5 and 4, both of them being negative, and that should give me those factors, x minus 5 and x minus 4, because thankfully I had a 1 in front, so I could just take those magic numbers and not have to do the grouping. So I'm going to write that over here to the right, so x minus 5 and x minus 4. In the denominator, we had the x minus 5 hanging out. Now I'm going to divide, which means I'm going to multiply by the reciprocal here of this thing. So it's going to be product, and then I'm going to flip that, invert it after I'm going to factor. So here, let's take a look at this right-hand side. Notice these both have an x in common. So I have x as the greatest common factor coming out. And if I divide by x here, I get x plus 4. Now, before I invert it and multiply by the reciprocal, I want to state x can't be 0, and x can't be negative 4 before I flip it. Once I invert it, the x is up here, and the x plus 4 is going to be up there, and it appears like it wasn't a problem. Well, originally it was. So even though I flip it, it's actually a domain restriction here, along with what we're going to say is x can't be 5 here. So if I'm keeping track of domain restrictions, x can't be those things. Now, in the top of this right-hand rational expression, there's a difference of squares. So I'm going to factor that very simply by square rooting the x squared and the 16 to be x and 4, and then conjugates. So plus, minus, factored. And once I factored, I'm going to go ahead and put it on the bottom, the denominator of this inverted reciprocal here. So I got x plus 4 and x minus 4. And then at this moment, now that I have this new problem, this x plus 4, x minus 4, we got to discuss whether or not it adds any points of discontinuity now that I flipped it. So here we have x minus 4. The x plus 4, I already took care of it. It was back here. But then I'm going to go ahead and add x can't be 4 as well. So I've got a list of 4 points of discontinuity. I got the 5, the 0, the negative 4, and then positive 4. Now that I've noted that, we can just vertically reduce. So I've got the x minus 5s can cancel. The x minus 4 is way over here, and the x minus 4 over there, they're going to cancel. So that's a weird, like, sideways 1. It's still a 1, because even though this one's over here and that one's over there, multiplication can be done in any order. So I could just rearrange it and move this x minus 4 vertically. If you like it that way, you can do that. And then finally, we have this x plus 4 Right here, that can vertically reduce. So everything reduced out except that x right there. The answer is x, comma, x can't be 5, 0, and plus or minus 4. But that part isn't what this question called for. The answer is just what the simplified version was of this rational operation of division, and the answer is just x.